the half-life question. With background radiation. So there are questions in which they mention the background radiations, how to solve a question related to background radiation. Last session, we discussed how to solve a question without background, like only the radiations from the source are given. So after every half-life, the radiation from the source will become half of its original value. Example, the detector record 500 radiations calculate the number of radiations detected by the recorder after 10 days if half-life of sample is 5 days and the background radiations are 40. So this is a question. The detector records 500 radiation. Calculate the number of radiation detected by the recorder after 10 days if the half-life of the sample is 5 days and the background radiation are 40. So basically what the detector is recording, like if this was a detector, so what detector is recording? The detector is recording two things. Number one, it is recording the radiation from the source, and it is also recording the radiations from the surrounding. So a detector is giving both radiation, it's from the source and as well as the surrounding. So what we can say, the reading on the detector is equals to source radiation, I'm writing in short source, plus background. So how many radiations the detector is recording? In the beginning, the detector is recording 50 radiations. So reading on the detector is 50. If background are 40, if 40 of them are background, how many radiations are from the source? How many radiations the source will, or from the source, if 500 total radiation detector is recording, out of 500, 40 of them are recorded or due to the background. How many radiations are there from the source? $500 total radiations are there from the detector recording. Out of 500, 40 of them are due to background. How many radiations are from the source? So that is equals to 460. So 460 radiations are due to the source. And after half-life, only the source radiation will become half. The background will not change. So after half-life, after 5 days, because the half-life is 5 days, so after 5 days, what will be the source radiation after 5 days, after half-life? So what is half of 460? That is 230. So source radiation will be 230 and the background radiation are still 40. So how many are there due to the detector? That is 270. The background radiation more or less remain constant. Only the source radiation will become half. Then after further 5 days, because we want the total after 10 days. So after further 5 days, the half-life is equals to 5 days. So after every 5 days, the amount of radiation will become half of its original value. So the source radiations will be half of 230. So source radiation will be 115. The background will remain 40. So when we work out what will be the total radiation will be source plus the background, that is equals to 155. So after 10 days, because we want the total number of detector reading after 10 days. So after 10 days, it will be, because first half-life 5 days, second half-life 5 days. So the total time interval is equals to 10 days. So after 10 days, the detector will record 155 radiations. Is it clear? So only the source radiation will be half. When detector is there, the detector records both source and background. So source radiation after every half-life, the source radiation will be half. As you can see, originally it was 460 become 230 and 230 become 115. Another example, a similar example. Calculate detector reading after 9 days when half-life is 3 days. The initial reading on the detector, so the starting or initial reading on the detector is 1500 and the background counts the background radiations are only 20. So the reading on the detector is equals to the source plus background. That is what the detector reading is there. So the detector is reading 1500. Out of 1500, 20 are background. How many are there from the source? Because the detector is recording total 1500. So 1480 radiations are due to the source. Now after half-life, only the source radiation will change. So I don't have to do all the steps. I can just change the source radiation. After half-life means after 3 days, it will be 740. Then after further 3 days, it will be 370. Then further 3 days, 185. 370 divided by 2. So 185. So total, the source radiation after 9 days will change into 185. The background radiations will be 20. So what the detector will record, what will be the reading on detectors when we add, it will be 205. Is it clear? Because after every half-life, only the source radiation will become half, the background and reading will remain constant. So you have two types of questions related to this half-life. One question included the background radiation and another question does not. So if it does not include directly, we just half the original value. But if it include, first we'll find the number of the source radiation and find this number of source radiation, and after every half-life, it will be half of its original value. Same way, we can also use a decay curve. A decay curve shows a change in radiation or amount of radiation or number of radiation coming out with respect to time. So you may have a decay curve, and this decay curve is always the amount of radiation, the number of the radiation which are coming out from the source are decreasing. In the beginning, you will have a maximum number of radiation, but with the passage of the time, the number of radiation are decreasing. Because in the beginning, you have more radioactive atoms. When the atoms become stable, they are not emitting out more radiation. That's why the number of the radiations which are coming out from the source decreases. On x-axis, you may have activity. What is the meaning of activity? Activity means number of radiations coming out in 1 second. So how many radiations are there in 1 second? That is known as activity. And the unit of the activity, it is becquerel, denoted by BQ. You can also use other unit like counts, radiation, but becquerel is also there as one of the unit. On x-axis, you have time. So same way, when you're solving a question related to the decay curve, you can also find the half-life, and you may have a decay curve with background or without background. So same way we will solve. Example, if this is a decay curve which does not include a background radiation, means these are the radiations from source only. So if the radiations are coming from the source only, how we can work out or how we can find the half-life using a decay curve? So if these are the source radiations, example 100, 200, 300, and 600. And this one is 1, 2, 3, 4, 5, 6. Now, how to find half-life from decay curve? So how we can find the half-life from this decay curve? So these are the radiations from the source only. So what you can do, you can take any value. It's up to you. You can take any value. Like example, I took 500 as my first value. When I took 500 as my first value, what is the time when the radiations are 500 from the source? So that is equal to, if the time axis, it can be in second, it can be in minutes, it can be in hours, depending on what is the sample. So example, when the radiations were 500, the time interval was 1 minute. What is half of 500 after half-life? How many radiations will come out from the source? So after half-life, 250 radiations will come out from the source. So I will find 250 on the graph, which is half of 500. And we will draw a line and find the time interval. Example, when it's 250, say this is about 4.4 or 4.5. So time is equals to 4.4. Now what is a half-life? Half-life means time it will take to become half of its original value. What is a half-life? It was 500, the radiations were 500 when the time was 1 minute. The half of 500 is 250, so time is 4.4. What is the time interval when it changes from 500 to 250? The time interval in minutes. So that is equals to 3.4 minutes. So the half-life is equal to 3.4 minutes. Because half-life is the time taken by half of the sample to be stable. And it's up to you, any value you can take. You can take 400. So if you took 400, then half of 400 will be 200. If you took 600, half of 600 will be 300. So this is a decay curve which does not include a background. The radiations are coming from source. That will be mentioned in the question, that whether this graph include a background or it does not include a background. When the half-life is the time taken to change half of its original value. When example we took 500, so when we took 500, the time interval was 1 minute, and after half-life the radiation will become 250, and when the radiation become 250, the time interval was 4.4 minutes. So what is the time interval when it, or how much time it took to change from 500 to 250? So that is 4.4 minus 1, which is equals to 3.4. The time interval to change from half of its original, or change to half of its original value, that time interval is known as half-life. Is it clear? This is a question in which a decay curve is there which does not include a background. Like there is no background radiation, surrounding radiations are not there. This is specially radiation from the source. But there might be a question in which a decay curve may include with background. So radiations coming from source and surrounding. Example, This is a graph, a decay curve. Time is there in hour and number of radiation. And the question is, the background radiation are 25. Are 20. And we have to find the half-life. So you will have these number, like example, say this is 20, 40, 60, 80, and 100. Now, as we know, this graph, these radiations are not only because of source, this is because of source and surrounding. So the detector reading is because of source plus surrounding. Now, on x-axis, we have the time interval, example 1 hour, 2, 3, 4, 5, 6, and so on. Again, it's up to you. You can take any value. Example, I took 80. So when I took 80 radiations, so these 80 radiation include both. It includes source and surrounding. The line does not appear to be straight, but because just for explanation, I'm using the number. So that is 1 hour. Now, this is a detector reading. If detector reading is 80, surrounding background radiation are 20. How many radiations are there from the source? If detector is recording 80 radiation, out of 80, 20 are due to the surrounding. How many radiations are there from the source? So 60 radiations are there from the source. Because the detector record both source radiation and surrounding. Now after half-life, the source radiation will only change. How many source radiation will be there after half-life? So source radiation will be 30. So if source radiation are 30, surrounding are 20. So what will be the detector reading? So the detector reading will be 50. So when I'm finding the half-life in this case, when I'm finding the half-life, I will not draw, because half of 80 is 40, but I will not draw a line from 40. I will draw a line from 50. And I will draw a line from 50 and find the time interval. So when the detector reading was 80, the time interval was 1 hour. When the detector reading is 50, the time interval is 2 hours. So what is the half-life here? So the half-life is equals to 1 hour. Is it clear how we work out the half-life? If a question include surrounding radiation, if a question include a surrounding or the background radiation, then we have to find first the source radiation, because after half-life only the source radiation will become half, not the background radiation. And half-life questions, the half-life question without a background radiation. So after half-life, all the radiation, because that is from the source, so it will become half of its original value. Any doubt in this? Because the detector, these are the detector reading, the detector is recording both radiation. So when you place a source in front of this, so there are 60 radiations because of source, and there are 20 radiations because of surrounding. So the detector reading on the detector was 80. But after half-life, when there is a half-life, after half-life, what happened? Only the source radiation will be half, the surrounding radiation will remain same. So after half-life, the source radiation will become, if it was 60, now it will become 30. But still the surrounding radiations are there, which are the background radiation, they are still 20. So what will be the reading on the detector after the half-life of the source? Because we are finding the half-life of the source. So reading on the detector will be 20 plus 30, that is equals to 50. Then the Rutherford experiment is there. A Rutherford experiment to find the structure of an atom. What Rutherford did, he took a very thin metal foil and in a vacuum, in this region of a vacuum, he target this by fast moving alpha particles. So Rutherford carry out an experiment. In his experiment, he took a metal foil and he target this metal foil by fast moving alpha particles, and this surrounding is covered with a fluorescent screen. What is a fluorescent screen? The fluorescent screen glow. When the particle hit the screen, it start to glow. So what he observed that most of the alpha particles are able to pass through it. That is his observation. Most of the alpha particles are able to pass. Few of the alpha particles deviate or change their path, and few of them bounce back. So these are the observation of Rutherford experiment. What we observe, you should know the observation, and then from observation we'll discuss the conclusion. So what are the observation of Rutherford experiment? What he observed? Number one, he observed most of the alpha particle, fast moving alpha particle pass through. Few of them deflected and few of them reflected. These are the observation. Now from his observation, what are his conclusion? What he conclude up from his observation, this is what he see. He set up an experimental setup. You should also know that he placed a metal foil and he target this metal foil by fast moving alpha particles in a vacuum. And what he observed most of the alpha particle pass through, few of them deflected and few of them reflected. So what are the conclusion of his experiment? Like what he conclude? So conclusion by Rutherford, what he conclude? He said that most of the alpha particle pass through. So what he said from his observation, he said that major portion of atom is empty. So he suggested that major portion of the atom is empty. That's why most of the alpha particle passes through. Like example, if I draw the structure of atom, we have a nucleus, and around the nucleus, electrons are there moving in definite region, shells. So as most of the alpha particle are able to pass through. So what Rutherford think about this observation? He suggests that because most of the alpha particle are able to pass through a material, so what he conclude, he said that major portion of the atom is empty. That is why most of the alpha particles are able to pass through. Or size of the nucleus is very small compared to the atom. Yes, it is empty or vacuum, like nothing, no particles are there. So there are only regions where the particle exists within an atom, but most of the alpha particle are able to pass through. So this was Rutherford conclusion, and you have to learn his conclusion and observations. He conclude that major portion of atom is empty. That's why most of the alpha particle are able to pass through. The second conclusion, second observation was few alpha particle deflected. So the second conclusion, why the few alpha particle deflected. So what he explained, how he explained this observation, he said why few of the alpha particle are able to deflect or change their direction. As an alpha particle moving closer to the nucleus, like charges repel each other. So the nucleus, which is positive charge, repel the alpha particle. So as the like charges repel each other, that's why the alpha particle changes the direction. So his second conclusion from deviation or deflection, what he said nucleus contain charge same as alpha particle, which cause deviation or deflection. That was the second conclusion which he drew from his second observation. So first observation, because most of them are able to pass through, he suggests major portion is empty. Few of them deflected or change their direction. So he suggests that alpha particle and the nucleus have the same charge. That is why like charges repel each other. So alpha particle deviate from their path. And the third conclusion was few particle bounce back or reflected. So how few particle bounce back or reflected, how he conclude that, or how he explained this observation? He said that because if, for example, reflection can only occur when two matter collide with each other. Like example, like there's a collision or there is a interaction of the matter. So what he conclude, he said alpha particle, if it is directly hitting the nucleus, it will bounce back. So from what he conclude from this, he said the mass of nucleus is present, mass of atom is present in the nucleus that is why alpha particle bounce back. So these are the three conclusions which he draw. There are more conclusion of his experiment, but other conclusions are not correct. So that's why it is not included. Because there was a conclusion, the wrong conclusion was there. He was saying that electrons are continuously moving around the nucleus. So as the electrons are moving around the nucleus, they're losing their energy. So he suggests you don't have to learn this conclusion. So he suggests that as these electrons are moving around, they're losing continuously energy. So if electron is continuously losing energy, a time will come when this electron will collide with the nucleus and the whole atom will vanish. But practically this does not happen, that atom vanish by itself. That's why this conclusion is not included. So you just have to learn three conclusions and observation. Number one, most of the alpha particle, major portion of atom is empty because most of the alpha particle passes through. Few of them deflected or deviate as they're coming closer, and few of them bounce back as they hit the nucleus. So three observation and conclusion you have to go through. Is it clear? The experiment of Rutherford, the Rutherford experiment.